Fuel is a modular execution layer, and you can kind of think of it similarly to Optimism and Arbitrum in the sense that it's a chain where you can offload execution. So it's a chain that only handles execution. And by execution, we mean changes to state, updates to state. So this is the environment where developers like you write smart contracts. And this is the place where those you can like handle those updates to state that come with those contracts. A few of the things that make Fuel stand out for me as a developer. Number one, it's developer experience. And that's kind of what I was tweeting about yesterday that you'll see today as you're building. One of the main value propositions of Fuel is, look, we're going to take this developer ecosystem that we know is a bit fragmented, and we're going to build everything to be vertically integrated, to be super seamless so that everything works together. So what I mean by super fragmented is if you have been coding in Solidity or you've been, coding on Ethereum, then one team built the EVM, another team built the language Solidity, another team built Hardhat, a different team built Foundry, a different team built WAGMI, a different team built Ethers. And sometimes it's hard to get all of these different versions and all these different configurations to work well with each other. Sometimes I find myself having to roll back a version because these versions aren't compatible. I find myself having to figure out what version is most stable that goes along with this other package that I'm using. And that's kind of annoying. And that's kind of what Fuel looks at and says, how can we create a better developer experience so that as a developer, you don't have to think about all these things and it can just work. So that's the thing I want to highlight today. The other cool things about Fuel that really stand out, and that's kind of like the main thing that you're going to always hear us talk about, is parallel transaction execution. So we have our own VM. So we're not EVM. We have the Fuel VM. And the Fuel VM is the EVM with a bunch of improvements that the Ethereum community has wanted for a long time and has proposed, and people agree objectively like this would be good. But for one reason or another, usually the need to keep backwards compatibility, they can't implement it. So on this page that I'm going to send you guys again here, I put together a list of EIPs, which is basically like plans for suggestions for how to improve Ethereum and the EVM specifically, that have been written by the community and that people are like, yes, this is good. And then side by side in this table, you can see how the Fuel VM implements these. So the difference is that the Fuel VM isn't bound by, kind of like the need to maintain backwards compatibility because you're building a brand new VM. So you're able to learn from the great things of the EVM and the not so great things of the EVM, and then put them together and make a better VM. So again, I don't have more time to get into that stuff because I really want us to get through this whole workshop. So now we're going to get started. So what I recommend for this workshop is for you guys to just watch and learn. I'm going to link the guide that we're going to follow so you can do it at home. I'm just going to link it right now so you guys are not anxiety taking notes because it's all written out right here. I'm going to paste it in the chat. So again, what I recommend is just to watch and follow along, ask questions, because you'll be able to do this at home, but later on today, you won't have me to ask questions. So focus on the stuff that I'm writing, focus on, understanding anything that that might not be clear immediately. And then later on today, or, some other time you can build this. Also, I'm going to close my Zoom now to open VS Code and share my screen. So if anyone has any questions, just turn off your mic, totally chill, and no worries. So I can't see the chat anymore and I can't see any faces. So if you need something, unmute. So like I said, you can go ahead and try to install that stuff. It might take a minute if you don't already have Rust installed. But if you're already at that point where you have Rust installed and perhaps you got the email around installation instructions yesterday and you're ready to go, then you can try to follow along. All right. Meanwhile, while I'm setting this up, how many of you guys have programmed in Rust before? But you need to unmute so I can hear you. Nobody.
Getting a little bit with Solana.
Same Solana
Okay. A few people from Solana. Anyone else?
and Polkadot a bit.
And Polkadot.
Just for fun, try it a couple of a page of the Rust book.
Nice.
Yeah, I did some development.
Cosmos.
Yeah, me too with Cosmos.
Isaiah. Okay, cool. All right, I'm gonna share my screen now. All right, so on the left, on the right, I have the guide that we're following, and I'm going to leave it up. Can you guys see this? My screen's kind of big, so sometimes the dimensions get messed up.
Can
on
you
video.
please zoom the screen? We can't really see it.
How about that?
Better now.
Is that good? Okay. So in this workshop, we're going to build something that we're nicknaming Web3 RSVP. So it's an event creation platform similar to maybe like Eventbrite or Luma, where users should be able to come in, create an event, set information about the event, like the name, the max capacity, how much a ticket costs, etc. And similarly, on the same platform, users should then be able to come and RSVP to existing events. So this is a super, super simplified, super bare bones version. But the hope is that you'll be able to take this home and then iterate on it and make something beautiful. So the first thing that we're going to do is, okay, we already installed this, let's say. And just some notes before getting started, you're going to hear me use different terminology. So just we're on the same page. When we say fuel, we're talking about the fuel chain. The fuel VM is the virtual machine. Sway is the language we're going to be programming in. That's the Rust-based language. And then fork is like the tooling management system. So if you ever get confused, you can just kind of go up to this key, but it'll be super simple. Just remember fork is for tooling, and then everything else you really don't have to know. Okay, cool things about Sway. There's 4 different types of Sway programs. You can have a contract, predicate, script, library. Today, we're going to go over contract and library. We won't go over scripts and predicates, but this is one of the super unique value propositions of Fuel as well that Ethereum and the EVM don't have, is this ability to execute code via scripts, which I won't get into, but I really encourage you guys to read more about what that means. So inside of whatever folder is maybe your workspace, what we're going to do is we're going to create a new folder. We're just going to call it Minority Workshop, maybe. And then inside of it, we're going to create a project with fork. So the way you do that, I know it's really small. This terminal doesn't zoom for some reason. So I'm writing fork new. And then here you're going to write the name of your smart contract project. So I'm going to call this RSVP contract because that's the name of this project that I just nicknamed it. And now if we open this up in our code editor, we can start doing all the fun stuff. So I'm going to zoom in a bit. So when you create a new fork project, this is what your folder structure looks like. You have a source folder, you have a test folder. Inside of your source folder, you're given an example contract. And in your test, you're given a test that you can actually just go ahead and update a few lines, and then this will work for this file. So we're not gonna get into the test today, just because we don't have time, but there's this guide in the docs that I sent you guys, Developer Quick Start, that goes through creating a contract and testing it, but we're not gonna do that today. Cool, so the first thing that we're gonna do, and what is considered best practice, is that in Sway, you define what's called an ABI. So an ABI defines an interface. So it just kind of shows what this function looks like without actually implementing the body. So if you're coming from a language, maybe like C++ or Java, you should be familiar with this, but maybe if you're coming from something like JavaScript, you might not have seen this before. And it's really not tricky or anything. It's just a new way to kind of like organize your code. So in order to define our ABI, we're going to create a new file because this isn't going to go in our main file. And here I'm calling it event platform dot SW. And here's where we're going to define this ABI. So remember, when we're making this program, we need to be able to handle a few things. The first thing we need to be able to handle is creating a new event and setting the details about that event. The other thing we need to be able to handle is a user RSVPing for an event. Now, if you wanted to really implement this, you could probably have many more functions, and I actually encourage you guys to check this out. This is actually a recreation of the project we did here. I know there's a few people in this lecture who actually took this course. So if you're interested in kind of comparing how Solidity and Sway works, this is a direct rewriting of this smart contract. So maybe I'll just link you guys here. So yeah, same thing, RSVP to an event. So we're only implementing 2 of these functions for time, but here there's a whole set of other functions that you could implement at home and get a really good side-by-side comparison. So let me just send this to y'all. How do I do this? There we go. Zoom in more, please. Can you guys not see? Okay, if y'all can't see, y'all gotta say something, okay? I think that's good.
Looks good.
Okay, here. Okay, cool. So I'm just going to go ahead and copy and paste this, but then we'll talk through it together. So any Sway file first starts off with you defining what kind of file it is. Remember, we said there could be a library, it could be a script, it could be a contract. We need to know what it is. So that's why we start off by defining library event platform. Now, the concept of a library is that so other developers can use this ABI and then like use your functions, use this library. So if you've ever written literally in any language, you know, there's like, oh, there's a big number library, or oh, there's a library specifically to handle, I don't know, scientific numbers with like 20 decimal places. So the idea is like some developer wrote this, put it into a library, packaged it in a way that other developers can, you know, in JavaScript can npm install this and take advantage of it, like similarly in other languages. So that's exactly what's going on here. So you could create this event platform library and then potentially, you know, I don't know, someone creating, I don't know, a music-based platform could potentially use this library because they could apply it to their concept in their application. So that's why we're doing this as a library. So let's walk through this. So here in the standard library, we're just importing a few things, identity and contract ID. Now, this identity, you'll see how it's used in a second, but it's basically how you get message.sender in Solidity. I'm not sure what it's like in Solana, but basically how you find the address of the current user that's sending a transaction. So that's what that is for. And then a contract ID does something similar, which you don't have to get into. So we define here two functions in our ABI, event platform, create event and RSVP. Now, the one thing that you might notice that like stands out as being really ugly to look at, and it's how I felt when I first started writing Sway and Rust, is like this line. It just looks really scary and horrendous. Honestly, there's like too many signs and it's just not pretty to look at. But this is actually one of the most powerful features of Sway and one of the biggest value propositions for Sway as a blockchain language. So what this does is this is called an annotation that denotes what kind of access to storage the function has. So we're denoting this function, this being the preceding line, has access to both read and write to storage. Whereas maybe potentially, you know, you're writing a function that doesn't actually need write access and it only needs read access. So in our case, we need both because we're going to be creating an event and storing this, and we're going to need to store the event details in storage. Similarly with RSVP, we're going to need to store something in storage, but maybe if we wrote a function called get number of events, perhaps, where we don't need to actually make any state updates, but we just want to read what's in storage, you could have your annotation look like this. And the reason why this is so powerful is because when you're writing in an adversarial environment like blockchain, right, where there's like money on the line, there's people's assets, this isn't a place where you can kind of apply the concept of like move fast and break things. Sometimes you don't even know that you're accessing storage when you're writing in Solidity and probably in other languages. So sometimes you as a user, you as a developer, don't even know that you're interacting with something that interacts with storage, and that could lead to unintended effects. So that's the great thing about this. It's like for the developer, it's super clear what access this should have and how it should be able to manage storage. Okay, cool. And then here you see all we're defining is the name, the arguments, and the return type. So our arguments for our event creation is the max capacity, is the number, the deposit, the event name. And for the event name, we're setting a maximum string length of 10. One of the things that is still a challenge with Sway being that it's such an early language. So yeah, maybe I should have prefaced that. Sway is a very, very early language, like compared to other languages, right? Even compared to Solidity, compared to Move. Move, they've been working on it for like 5 years, I think. I think Sway has only existed for like 2 years, maybe like 2.5 years. If there's any fuel people, correct me if I'm wrong. So one of the fun things and one of the not fun things is you'll sometimes run into things and be like, what the fuck, why doesn't this work? And it's like, oh yeah, it's in progress. The team is working on it. It's not out just yet. So like a few weeks ago, you couldn't do stuff that you can do now. So it's just another thing to keep in mind. And for this function create event, we're returning a type event, meaning like after you create an event, I want to actually return the event so that I can then surface it on my front end. For RSVP, we're just passing in an event ID. The user is going to say, I want to RSVP to event number 5, let's say. And then I'd also return an event so that we can surface to the user what event they just RSVP to, those details. Now, the next thing that we're defining in our ABI file, in our library file, is this struct. Now, the reason that we're defining it here versus in our main file is because, again, if you're thinking about this as a library, the person who's using your library will also need access to this struct because it defines how your event struct, how it's actually stored. So for people who maybe aren't familiar with structs, this is just a data type, kind of similar to an object in that it holds key value pairs of different mixed types of data. But this is specifically different than an object in a few different ways because structs are used in cases like this where you'll see exactly what I mean when we start coding, but you wouldn't necessarily use an object. And I think in Sway, actually, there's not even the concept of like a JavaScript object anyway. So it's not something that should be confusing, but if you're not coming from a language like C++ or Java, you might not have seen a struct before. So I just wanted to put that disclaimer out there. It's similar to an object. Okay, cool. So now we wrote our ABI. The next thing that we're going to do is now we have to actually go implement these functions, right? If you notice that these don't have function bodies, we have no idea how this function works. So now we need to go define what exactly do these functions do. So again, I'm just going to copy and paste and then we'll walk through this together for time's sake. Can you guys see this? I think it's, let me try to, it looks really big on my screen. Come on. Okay. Oh my God, there.
Yeah, we can see it.
Okay, cool. So again, starting from the top, you have to define what kind of file this is. This is now a contract, whereas remember, this was a library. This is now a contract. This is what we're actually going to deploy, and this is actually what users are going to be interacting with. So up here, the way that we kind of create the dependency and the connection between these two files is by writing dep event platform, which is the name of this file, and then use event platform. And this little weird symbol stuff just means use everything in here. Because for example, when you're importing stuff like this, you're saying, give me specifically access to this thing, like this identity thing, or in contract ID, give me specifically access to this. But when you use this notation, you say, give me access to everything in the file. So that's what we're saying. Again, we're importing some stuff from our standard library. And now this is the important part where we get to, where we're defining storage. So we're defining what are the variables that we're holding in storage. And these variables are what we talk about when we're saying storage access here. So when we're saying read write, we're saying both of these functions have full read and write access to both of these variables. So now to implement our first function, create event. So remember, we have to be able to do a few things, okay? So this is an event platform, meaning that there should be many events that can be created, not just one event. So we need some sort of structure, some sort of data type, some sort of data structure to manage all of these different events and somehow make it easy for us to read events as needed, right? So if we want to say, I want to specifically find event number 612, let's say, we need a mechanism to do that. So that's exactly why we're defining a storage map. And a storage map is basically just a hash map. It's just called a storage map because it's, you know, what the team decided to name it. It makes sense because it's storage, but it's just a hash map. And if you guys don't know what a hash map is, it's kind of like a, let me just show you real quick, just so we're on the same page. I'll just pray to the link God. Oh God, see, that was a bad link. Oh God, why don't none of these have good pictures? Okay, hash table, that's why it's called a hash table. It's like a hash table. Oh my gosh, this is horrible. Okay, here. So if you guys haven't seen a hash table, it's this way of organizing data and where you have keys and values, kind of like a JavaScript object. But the idea is that you can have a bunch of different data in here and access it easily via its key. So you can say, for example, give me key number 002, and instead of just holding a scalar, like maybe a string or a number, it can hold a whole ass other unique complex data type like a struct. So you can map numbers like 1, 2, 3, 4 to structs. So we're going to map unique numbers to this. So when we say, give me key number 1, it's going to give us back a whole event because that's what we're defining here. We're saying the key is a U64, which is a number, and the value is an event. So if you look over here, this is the key and here is the value. So that's exactly what we're creating here as a means to be able to access our events. Okay, I have to speed run now. What time is this over at? I have 15 more minutes. Okay, well, if anyone knows, just holler. So now, okay, now we're at create event. So how do we actually create this event? We have to implement the same argument type and return type that we did in our ABI, right? That makes sense. So now what do we do? So you'll notice the other variable that we're holding in storage is an event ID counter. Now, mind you, a lot of the ways that I'm writing here is kind of janky. This was trying to keep it super, super simple. Like obviously you definitely shouldn't do this in production. But again, this is kind of just for like keeping a very easy beginner friendly workshop. So we're setting an event ID counter and we're starting it at 0. And the way that we're producing this unique ID for every event is we're just taking the current value of this. So the idea is that as you create an event, you grab that current value and then you increment that number. So on the next event creation, there's a new unique ID. So that's what we're doing here. First line, let campaign ID equal storage.eventid.counter. So the way that you access these is just like you maybe would expect, storage.variable name. Cool. So now we say, all right, let new event equals a new instantiation of this event struct, which remember is this. It's called event because we called it event here. If we call this applesauce, it would be called applesauce here. So just keep that in mind. So that's exactly where the name comes from. This isn't like a reserved keyword or anything. This is simply highlighted because that's what we call this. So we're saying, all right, let's create a new instantiation of this struct, the unique ID being the campaign ID, which we got up here. The max capacity comes from the user passed this in. Remember, these are arguments. So this means we're expecting the user to pass this in. And when we build our front end, this is going to be passed in via a form. So like Luma, right? When you go in and make a new event, it's like, all right, it has a box for event name, it has a box for event time. That's exactly what we're going to implement. So all these arguments come from our end user. So we set the max capacity also according to that, the deposit according to the argument. Now the owner, being the person who created this event, this is how we grab their address, message.sender.unwrap. We call this unwrap method. And for a future implementation, we don't have enough time to go into it today, but a future implementation use of this is that you say, okay, the deposit or the payment, the price, the money should be released to this person. Because if I'm creating an event and I'm selling $10 tickets, I'm going to want that money, right? So that's something that you could implement by yourself. And now I'm going to leave some guidelines for how you can do that and kind of extend this project. Name also comes from the arguments and number of RSVPs. We're setting it to 0. So on every new event creation, it's kind of like a constructor where we're saying like on every new creation, this is what it should look like. Some of these are dynamic, meaning that they're passed in from our user. And some of these are not dynamic, meaning that we're hard coding in values like 0. All right, cool. So now we've created a struct, but the struct is just like floating in space by itself. We haven't done anything with it. It just exists, but it's not stored. So now the next thing we have to do is we have to actually store this into storage, like put it back in here, make an entry to our hash table or AKA our storage map. So the way that we do that is we say storage, right? We access this dot events, which is this, AKA our hash map. Storage dot events, we call the insert method, and then we let it know what is the key and what is the value. So remember, the key is this unique ID and the value is the entire struct. Then we go ahead and increment our counter because we don't want 2 events to have the same unique ID, obviously. And then finally, we want to return our actual event. So because we've already implemented our counter, we're going to go back 1 index and then return that. So we say let mutable. So this mute keyword is something that might be new to you guys. So all variables are by default immutable in Sway. And this goes along the lines of type safety, offering kind of like the most safe environment for blockchain developers where you don't do anything unintended. So you have to explicitly say when you want to make a change or when you want to have a mutable variable. So the way that you do that is with this mute keyword. So we're saying this is going to change from function call to function call because the selected event is going to change on every time, right? Every time you create a new event, it's going to be a different event. So we're saying, hey, this is going to be mutable. So selected event equals storage.events.get, and then the key is going to be the current counter -1. We could have moved this line up here and not done the -1 and just kept the normal one. But the idea is that we don't want to accidentally forget to move our counter up, or we don't want to accidentally like potentially run into some sort of attack where all of the event IDs are the same. So you increment first, just like around when you're thinking about reentrancy, you flip the flag first and then you give the money. And if that doesn't make sense, don't worry about it. We'll talk about that. Okay, now implementing our second and final function, RSVP. So now for this function, your user is going to say, I'm going to pick this ID and I want to RSVP to this. So what does that mean when someone RSVPs in the context of our struct? What that means is that 1, the number of RSVPs should go up, right? And we need to That's really the only thing that we're going to change, but that's the kind of the thing to keep in mind is like when you're dealing with these types of data types like a struct and you're constantly like, so here we created it, right? And here in this next one, we're going to update it. And like I said, for this one, this is a super bare bones example. You could extend this a lot to do like real kind of more like production grade functionality. So just keep that in mind when you're working on stuff like this to really look back at your data structure and understand what needs to change in this. So for us, what needs to change right now is just the number of RSVPs, because remember, we default set all of them to 0 upon creation. Okay, so then what we do is we go ahead and say same thing, let mutable selected event, because it's going to change from time to time, equals storage.events.get current ID, or sorry, event ID, which we get from the user, because remember that we're going to have a little text box where people pass in an ID. And then we check to make sure that the ID that they pass isn't out of bounds. So let's say we only have 5 events on the platform, but they pass in the event ID 100. That doesn't exist, right? So we need to handle that case. So we're going to say if the event ID is greater than what's available on the counter, then we're just going to, I call this a fallback because we're just going to show the first event. Obviously, again, this isn't something you would do in real life, but it doesn't matter. So in the worst case, we're going to return the fallback option, which is the first element in that hash map. In the happy path case, which is where they like type in a correct event ID, we're going to say, cool, now we found the selected ID up here, right? The selected event. We're going to increment the number of RSVPs just like you would expect to do it coming from JavaScript. You do this dot the property, and then you do your operation, which in our case is to take the current amount and add 1. And then again, now this is floating in space, like this change, this is like you did a git diff and now you have the RSVP is different. You need to save that. So what we do again is we do storage.events.insert. We pass in the unique key and then we pass in the struct and then we return it. So now remember, on both of our functions, we're returning the event. So now in our front end, because we're returning this, we'll be able to surface it to our users and create a UI where they can see, what event they just created or what event they just RSVP to. So this is what we have so far. And so we're going to walk through the process of building this and deploying this. Okay, and I'm not going to lie, literally my tweet yesterday was so real because I was working on this and it's just like, damn, you don't have to set up anything. You don't have to configure anything. Everything is just like here and it works. So let's do fork build. Let's expect this to build correctly. If it doesn't, if it finds errors, it won't build. That's one of the fun things about Rust is that it calls out errors at compile time. And one of the unique value propositions of Sway specifically. So, we call Sway, you might've seen it called the Rust-based DSL. So like that means domain. Okay, so what that actually means, right, is that it was created specifically for blockchain development in this context. That's exactly what it means, right? So this isn't like a general purpose language where you could maybe, do other things that you can do with Rust. It's specifically for developing for blockchain. So with that in mind, the compiler engineers wrote in some features that make it unique to solve problems of blockchain developers. One of those things being, for example, if in your contract you are vulnerable to a reentrancy attack, meaning that someone could potentially attack your contract and drain out all of the money unexpectedly, the compiler will actually warn you at this point where you do fork build. It'll say, line, whatever, you have a vulnerability. So it's tailored to the specific use cases that we're building for. And that just goes again, along with this whole concept of type safety and safety in an adversarial environment. So we went ahead and built this. I'm going to go back to my thingamabob. So you'll need to install the wallet CLI, which I already have, but the steps are here, super easy. And you're going to get a fuel wallet. So let me show you what mine looks like. So if you once you install and you do fork wallet list, it'll list out your wallet. This is my wallet address. So you're going to need to have that, but I already have that. So I'm going to skip ahead and I'm going to do fork deploy. And then here I'm passing in the endpoint for the testnet. So we're going to deploy this to our testnet. And we're setting the gas price to 1 because I'll just delete it so you can see, if you don't do this, it'll complain and fail saying that there's not enough. Okay, we'll see, it doesn't always do it, but sometimes it'll complain and fail about the gas being too low. So this disclaimer, so obviously the wallet is still in active development, meaning that it's not in its final form. In its final form, there'll be a nice browser extension, just like you would expect. Right now, it's all CLI based and it's just very immature. So we're gonna kind of have to go through some weird steps that feel maybe weird at first, but once you do it a few times, it's fine. So it says, please provide the address of the wallet you want to sign this transaction with. I have it right here. I'm gonna copy, just paste. And then it's gonna spit out my contract ID, and it's gonna ask me to provide the signature. So first what I'm gonna do is I'm gonna copy this contract ID. I'm gonna paste it here. Don't let me lose it. And the next thing I'm going to do is we're going to copy this transaction ID because it says transaction ID to sign. We're going to open up a new tab in our terminal and do fork wallet sign. We're going to paste in that transaction ID and then the index 0. And maybe I should, so hold on, password. So the reason why we did that index 0 is because if you do fork wallet list, you see this wallet is the 0 index wallet. So like potentially I could have 5 addresses or something and you could pick which wallet you want to sign with. I only have 1. So that's why, but that's exactly what this like 0 stands for. So cool. So then you have to enter your password and then it spits out the signature, which is what the other window was asking for. So now I'm going to take this, paste it into here. Oh, see, gas price is too low. So let me just do it now with this. Wallet. Okay, here's my new contract ID. I think it actually might be the same. I'm going to paste it just in case. Okay, transaction to sign. You go to your other one and you do fork. I don't copy this. Fork wallet sign. Okay, then you copy the signature over. Okay, great. Amazing. Okay, so now what we're going to do is, okay, so now our contract is built, our contract is deployed. Now it's time to create a front end to interact with this. So I know we only have a few more minutes, so don't worry, I'm keeping that in mind. So the next thing we're going to do is we're going to go CD out 1 level back into our main folder, because if you remember, we created a folder called Minority Workshop, and then in there we ran fork new RSVP contract. So that is specific to our, you know, quote unquote backend. And now we're going to go to a front end. So we need to step back and create a front end folder. And all these instructions are here, so don't worry. So we're just going to copy this. We're going to create a React app to make a simple little front end. You could also use something like Next.js. And after this gets created, we're going to install a few things. We're going to generate a wallet specifically for our front end, which again, this is something that's in active development that you won't have to do hopefully in the near future, but it's just the state that the wallet is at right now. And the way that we're going to do that is super simple. You just create a folder in the root of your project and paste this in and run this node command, and it spits out a new wallet for you. So let's do that real quick. Here, we're going to create a new file, create wallet.js. We're going to paste this in, save that. First, let me install this now. Okay, so now this is ready. We're going to go into our front end folder and install these things. So Fuels is the umbrella package that includes all of the main tools like wallet, contract providers, and more. Fuel Chain is the ABI TypeScript generator. So one cool thing, which I also tweeted about yesterday, was like, you don't have to do that weird thing in Solidity where you have to like, you know, deploy your contract and then copy the ABI and then make a folder and then like paste it in there in your front end. It'll just generate it for you. That's one of the cool things. So let me install the second thing. Did I already install it? No. Okay, great. So now we're going to run this command, which is what's going to generate the types for us. So let me run this so you can see. I'll clear this so you can see. Cool. So it generated our typings, and now in our front end, we have our contract factory, which is the ABI stuff that we need to build a front end. So that's great. Now that this is done, we're going to create that new wallet. So remember I said for interacting with the Fuel network, we're going to have to submit signed transactions. So the Fuel TypeScript SDK, which is what we're going to use now to build our front end, currently isn't supporting the wallet integration. So we have to create a non-safe wallet in the web app. So basically don't ever do this in real life. This is for development purposes only, because this is an active development. Again, in the end, you won't be able to do this, and you shouldn't do this. Just a little disclaimer. So we're at the step, I already copied this, and we're just going to run this command node create wallet.js. And I didn't even copy it. And this is going to spit out a address and a private key. And that we're going to use that real quick. So let me just go ahead and go get some coins. So we're going to take our address, go to the testnet faucet. Just paste our address in there. Okay, done. All right, so now we have coins to do this. All right, so now to the fun part. So we're going to go ahead and actually write out our front end. So in app.tsx, this is just a simple React application. We're just going to play on this page. I'm just going to delete everything. And I'm going to paste in what we have here, and we'll talk through it. So super simple. Let me go ahead and paste in my wallet address. So, sorry, this is my contract address. So I'm going to edit this contract ID with my contract ID, and then wallet secret will be replaced by the private key that was spit out from here when you did node create wallet. So that's this, and this is all written out, so don't worry if you don't remember or whatever. Oh shit. Okay, I'm using a Vim emulator on VS Code, and honestly it sucks. I did it because I'm trying to learn Vim, and it's honestly just not working for me. Okay, cool. So let's talk about this. I'm gonna make this full screen now. Okay, so starting from the top, so we're importing our ABI factory, just like you're used to in Solidity. We're setting our contract ID and our secret key, which is our private key that was generated. We're creating this wallet thing, which you don't have to really worry about what it does. You just copy and paste this, and we're setting in our testnet endpoint. And now is where we're starting to actually define and write how a user interacts with this contract from a web application. So in our default function, our default component app, we're setting a few state components, which I won't talk through completely, but we'll just talk through the interactions part, like how does the front end and the back end talk to each other. So let's look at what our thing looks like first. Let me actually just run this so you guys can see the vibes. See the vibes. So npm start. So remember, we want to have a form where a user, let's just make this big screen, can create a new event, and then where a user can RSVP to an event. Okay, so yes, I know this is ugly. Okay, that's not the point. I made it ugly on purpose so you guys could extend it. Okay, it wasn't on purpose. So here we have a kind of form thing to create an event, and then we have another input here to RSVP to an event. So remember, the things that we need to pass in are an event name, the max capacity, and the price. And then for an RSVP, we just need to pass in the event ID. So that's what that looks like. So that's this part. What you're seeing right now is we created a form. I'm not going to talk through too much of the React stuff because this is like kind of general stuff you can just kind of read about on your own. But basically, we made a form with a bunch of inputs where we're asking for the event name, the max capacity, the price. And what we do is down here, we have a button that when it gets clicked, oh, where is it? Oh, here. So this button that when it gets clicked, something happens. And the thing that something is one of two things, is that on submit, so when this form gets submitted, we're going to call a function called create event. And then down here in the RSVP section, we have another button, RSVP, right? Let me show you guys so you remember. We have one called create, one called RSVP. Both of these handle different things, right? So when one gets clicked, when the RSVP one gets clicked, we call one function. When the create event one gets clicked, we call another function. So let's look at the function and how you interact with our contract function in create event. So when that gets called, this is going to get called create event. So pretty simple standard React stuff where we're preventing the default and we're setting a loading variable to true just so that we can track the loading state. And here's the part where we're actually interacting with the contract. So in a try catch block, we're saying, oh, honestly, I have so many console logs, but we'll just leave them actually. They're really helpful when you're just kind of figuring out how Sway works. So this is how we actually are calling and interacting with our contract. So you'll notice we didn't have to set up WAGMI, we didn't have to set up ethers.js, which is usually what you have to do to interact with your contract, right? All of this is built into the TypeScript SDK, which is what we're using right now. And it doesn't even feel like you're like putting a bunch of pieces together. That's really what I love about this. So we're saving the results, the output in this value variable so that we can read it in a second. But what we're doing is we're saying in this asynchronous function, we're calling await contract.functions, which is just the standard like method for how you reach your actual function. So contract.functions dot the name of the function in your contract, which if we look here, it's called create underscore event. So that's why it's called that here, create underscore event. And remember, this needs capacity, price, event name. And here we're passing in capacity, price, event name. Dot transaction parameters. Here's similarly to when we deployed and we set the gas price to 1 so that it wouldn't get mad. We're doing the same thing here. And then finally, you invoke the function with this dot call method. Done. And what we're doing is I just logged out all the values and then, set some of the state things. And down here, when this flag is true, so when an event gets created, which gets flipped here. So when event creation gets set to true, meaning, hey, the user just went through the process of submitting an event. When that's true, then we're gonna output the new event that they just created. So let's go look at that real quick. So if I say per party, 100 people is the max and the price is $10, and I create this, the event was created. All right, cool. So now it's telling me my event was created. Here's the event name, my event ID, etc. Great. So now let's go through the process of what it means to interact with our RSVP one. So down here, remember, we have another input where we're asking the user to pass in the event ID. And when they click the submit button, we're calling a function here called RSVP to event. So let's go find it. Here it is, RSVP to event. Again, in a try catch block, super simple. We're calling it the same way, contract.functions.rsvp. Now, again, you'll notice it's called RSVP because here it's called RSVP. So these are the names that you're matching. We're passing in the event ID, transaction parameters, gas price to 1, and then actually invoking it. And here we're doing the same thing where I'm actually setting the state with what's returned from this value. So if we actually go look in the console, we can see what we're actually getting returned and how we're kind of massaging it out to work for us. So let's see. So can you guys see this? Okay, cool. So when we created the event, this is what actually got returned. So remember, we're returning the whole ass event. So this is what got returned. It's like this weird, like long, like kind of hard to read thing. So one thing that you'll note here is, remember I said we set a static length of the event name to 10. And here I only use 4, 5, 6, 7, 8, 9. So that's why it's giving this weird thing. But if I create something with 10, actually, you guys weren't supposed to do that. So here, if I create one of string length 10, then you'll see the name doesn't have like those weird characters in it because we took up the whole, we like used it all up. Really what it's doing here is it's adding the buffer, but that doesn't matter. So cool. So now that we have that, let me say okay to this. Let's walk through the RSVP one now. So again, we already just did. Okay, yeah, super simple. We're literally just setting the state, but now the only thing that's different is that when a user RSVPs, we also want to display the event that they just RSVP to so that we as developers, first of all, can check that they're actually RSVPing to their intended event, and 2, so that the end user, they can see what event they RSVP to. So again, we set a flag up here that says, hey, when this happens, that means a user has RSVP'd. So let's flip this flag to true. And that'll control the logic flow for down here. So we can say only display this if it's true. If it's false, meaning there has no RSVP has been created, we don't want to display this, right? Because it'll be confusing if there's no RSVP, but we're saying there's an RSVP. So that's what this logic does, is we say, hey, if this is true, then go ahead and display this. So far, where am I? So far we have 2 events. So let me just like make a few more events. Okay. Okay, so now we have event ID 0, 1, 2, 3. Let's do one that we can remember, like Sway Workshop. That works. Okay, cool. So now when we're RSVPing, if we pass in 4, we should get back Sway Workshop because that's what we just wrote, and we know that that's ID number 4. So let's try it. It says RSVP successful. RSVP confirmed to the following event, Sway Workshop. So cool, we confirmed we actually are reaching the intended event when we're running this. And remember, right, like all of this logic around actually finding the right event, that was all done in the contract. That's all the work that we did here to say, okay, if someone wants to RSVP, we're getting in an event ID and we're finding it and we're returning it. So all that logic was done on the contract side. And the front end side, the only logic that we're handling is the logic between these input boxes and actually invoking the correct function. So when you're first starting out writing dApps, at least for me, I remember it was like a little bit confusing understanding what logic lives where. So kind of the way that I like to just set it in a very simple, overly simplified way is just like all of your business logic is done in the contract. And then all of your other logic is handled in the front end. And by business logic, I mean like, what is the mechanism for identifying an event? What is the mechanism for storing a new event? Like all of the actual kind of like tasks you need to check for are done in the contract. And then this stuff is really just like how to take stuff from the user and make it go to the contract. That's all the front end is there for. And we're done. Like we did it. Like, again, this is a very simplified, overly simplified version.